Welcome to my new channel. Today I will discuss some numericals based on the capacitor. So first numericals I have taken. If this type of circuit is given, how to find the equivalent capacitance in between A and B. Okay. To calculate this type of circuit, first you have to make the simplified circuit. See, this point and these points are same. So first how I am making, you just observe. These are parallel. This C are parallel. Okay. Now this point and this point, see this point same. So I am making it like this. Okay. Now here this C is connected like this. I mean this point is B. So that's why I have taken this is B point. Now what about this one? So these are connected series. If we forget this part, now we can draw this C part also, and this is also connected to B. Okay. Now only one part left. Which one? This one. See, this is connected in between. Here means from the middle to B. To B also here I can give, because this point also the B point. Now this is easy to calculate, because this is C, 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 this is also C. Now see, I am giving this is 1 and this is 2. So what is the equivalent capacitance in between these two C? So C1 will be, these are parallel. We know for parallel circuit C parallel equals to C1 plus C2. If you take 3, then C3 will come. If C series equals to C1 C2 divided by C1 plus C2. Okay. Now see, these two C are connected parallel. So what is the equivalent capacitance in between them? This will be parallel, means C plus C. This will be 2C. Okay. What about this one? Suppose this you give, this is 2. So what about this C2? C2 also it will come 2C. Okay. Now see, this is 2C, this is 2C. We can say these 2C and C are connected in series. So this C3 will be how much? 2C into C divided by 2C plus C. It will come 2C square by 3C. So 2 by 3C. Now what about this one? This C4 will come. C and 2C, these are connected in series. So this will come 2C into C divided by 2C plus C. It will come also 2 by 3C. Now see, this part and this part are parallel. So net will be, or C equivalent will be this C3 plus C4. This will be 2 by 3C plus 2 by 3C. C equals to C, it will come 3 will be LCM, then 4 by 3C. 4 by 3C. This is the answer. In this problem, you have to calculate the equivalent capacitance in between A and B. Now see here, these wires are connected in between these 2 points. Now the rules are, if there is only wire, then we can consider this point is A, so this point will also be A, because only there is wire. If there is a capacitor, then we can't consider these 2 points are same. So if this is B, so this point will also be B. Now how many points we got? Only A and B, means 2 points. So first capacitor is connected in between AB. Okay, AB. Second also A to B. Third also A to B. So these 3 capacitors are connected in parallel. So the C net will be how much? C plus C plus C equals to 3C. Okay, clear? Now what about this part? In this part, see, here this point is A, this is where, means this point will also be A. Now what about this point? See, there is capacitor is connected. So we can't take this point as A. So we have to take the different name. So P I am writing. P, so this point will also be P, because this is where, so this point will also be P. Now here how many points? A, P and B. 3 points we got. A, P and B. So first capacitor is connected in between A to P. Second A to P. P to A or A to P, same things. Third also A to B. And what about this part? In this part C, these 2 points are same. Means in case of battery, plus and minus is connected. So what will happen? There will be short circuit. Okay. So we can neglect this part. So what about this C? This C is connected in between P to B. P to B. Okay. Now see, these are easy. These 3 capacitors are connected in parallel. So Cp will be 3C, and this 3C and this C is connected. These are connected in series. So C will be 3C into C divided by 3C plus C. This will be 3C square by 4C. This is 3 by 4C. This is the answer. In this problem, how to calculate the equivalent capacitance in between A to B, where all the values of capacitors are given C. Here we can calculate the net capacitance in between A and B by charge distribution method. So the question may arise, when we will apply the charge distribution method. So see, in case of Wheatstone bridge, we have read when C1 by C2 equals to C3 by C4, the circuit was like this. The circuit was like this. Then if this is C1, C2, C3, C4, this is A and B. So if C1 by C2 equals to C3 by C4, then we can neglect this part. But if these ratios are not same, then we can apply the charge distribution method. Here that method I will apply in this problem. Okay, let's go to the numericals. First, let me discuss what is the charge distribution method. See, suppose I am taking one easy circuit A and B. See, these are connected in parallel, but by charge distribution method, how to calculate that I am showing. See, first method is, you have to consider one imaginary battery across the terminal and choose the plus Q charges passing from plus, means this is plus terminal, this is negative terminal, and minus Q charges flowing from the negative terminal. Then the second is divides the charge, means distribute the charge. So here it is plus Q, means there will be plus Q, there will be plus Q, this is minus Q, and here the charge will divide into 2 parts. Suppose this is Q1, this is Q2, so here Q2 will come, polar plus, this will be minus Q2, like this. Okay, here is also same. Now the third process is choose the closed loop. This is closed loop. So in closed loop, do summation of del V equals to 0. This is called the Kirchhoff's law. KL I am writing. This Kirchhoff's law we will study in Ohm's law chapter. Now do this one. And the last part is, this is the capacitor, this is plus, this is minus. If the charges flows from plus to minus, if we consider here clockwise I have taken. So clockwise means we are going from plus to minus. Plus to minus means plus to minus. So that time del V you write del V equals to minus Q by C. And in the second case, if it is minus to plus, then take del V equals to plus Q by C. Okay, del V equals to plus Q by C. And the last method is choose any path from the battery. Obviously this path will be closed, and do the summation of del V. Suppose this path I am taking from battery to capacitor, and do summation of del V, which is equals to plus minus of 1 by C. 1 by means here actually Q by Q, because charge is, that charge you have to consider Q by C. Okay, C means if there is 2 capacitor, then if we consider these 2 as 1, then net will be CE. That's why plus minus I am taking. Plus minus means if plus to minus, then you will take minus. If minus to plus, then you will take plus. So in general case, I have taken here plus minus. Okay, this is the charge distribution method. So this one I will apply over here. See, here consider one battery, imaginary battery was there. So I am taking, see here, in the previous case I have taken plus Q charges coming from plus terminal, minus charges coming from minus terminal, minus Q charges coming from minus terminal. Here we can take the plus 3Q charge or whatever. You can take plus 3Q plus 6Q plus 9Q, whatever. I am taking here the plus 3q charge from plus terminal. 3q, what is the advantage of taking 3q? Here the 3 paths are there, so q will distribute. That's why I am taking plus 3q. So q here plus q, here also plus q. Now if this is plus, this is also plus, this is also minus. Now here this is q, here it is getting 2 paths. So that's why it will divide into 2 parts, which is plus q by 2, which is plus q by 2. This will be plus q by 2, this will be minus q by 2. Here you come, this is plus q, this is minus q, and here it will divide into 2 parts, which is plus q by 2 and it is plus q by 2. This is minus q by 2 obviously. Now come over here, this is the B point and this is minus 3q. Here plus 3q I have taken means minus 3q I have to take, because in previous case what I have told, plus q you have to take from plus terminal, minus q you have to take from minus terminal. So from plus terminal I have taken plus 3q, means from minus terminal I have to take here the minus 3q charges. Now see, minus 3q means here it will be minus q, here it will be minus q, here it will be minus q. Now it is minus q, it is also plus q. Now here it will be divided into 2 parts. So here actually it is coming minus q, so here it is minus q by 2. Now it is c, again minus q by 2 came. Okay, all the values are c, huh? Now here also see, this is minus q, this is plus q, and here it is given plus q by 2 and minus q by 2. Why? Because it is to minus q. It is minus q. Here it will be minus q by 2, here it will be plus q by 2. Where from here see, it is plus q, it is plus q by 2, this will be also plus q by 2. This is this is minus, this will be also minus q by 2. Okay, clear? Plus minus, all the capacitor got the charge. Now take any path. See here the charge is, if we take the shortest distance, then this charge is covering only 3 paths. How? See, this is 3 paths from A to B. From A to B only 3 paths are possible. No, different paths are possible. More than 3 are possible. But minimum number how much? Minimum number how many? How many minimum number is possible? 3. Because see, this is and this is 3. This 3. This 3. So I will take any one path. Suppose this is A point, this is X point I am telling, this is Y point I am telling. Okay. So for AXY. Now we will do what we will do? The summation of del V we will do. And we will equate this into the equivalent capacitors. First see here Q charge is coming. So this path I have taken means plus to minus I am coming. So minus q by c, because q equals to v equals to q by c. Now here see, it is plus and it is minus. So plus to minus, minus q by 2 divided by c. And here it is plus to minus, so minus q by c. Here it is charges q. So equals to plus or minus. Plus or minus, because here if we consider one battery over here, then see I am going plus to minus, so give minus sign over here. Then minus, if we consider these 3 capacitor is 1 capacitor, then the charge how much I have taken? 3q charge I have taken. So 3q divided by c. Now calculate this. This is c minus q by 2 minus q equals to minus 3q by ce. And it is minus 2q minus q by 2 divided by c. This is minus 3q by ce. And here 4 minus 1. Minus you cancel, so it will come 5q divided by c equals to 3q by ce. So ce will come here. It is, so here 2 is there, no? So this will be also be 2, means 2 will come over here, isn't it? So 4 minus 1, so 2 will come over here. So it will come 6 by 5, q cancel, 6 by 5c. So this is the answer. Okay, clear?